Welcome to this session. Today we are going to discuss the recurrence relation, which is the fourth module. So before going for the recurrence relation, we are going to complete first generating functions. So what is a generating function? How we are going to construct a generating function whenever any sequence will be given, and whenever the function is given, then how to find out the generating function. So that and all we are going to discuss in this class. Now, the syllabus concerned, this is the syllabus according to our IARE. So here I am going to follow, these are the prescribed textbooks, Grimaldi and D.S. Chandrasekharaya. So these two books that I am going to use to solve the problems are whatever the contents we are going to discuss in this recurrence relation, I am going to get from these two books. Now, what is a generating function? Suppose a sequence of real numbers, let us say A0, A1, A2 and so on, An and so on. Infinite sequence. It is an infinite sequence is given. Now for this sequence, if any function, if we are going to express like this, f of x is equals to a0 plus a1x plus a2x square plus and so on, then this is infinite series. I am going to represent like this. So this is known as a generating function. F of x is equals to summation of r x power r, which is known as a generating function for the sequence a0, a1 and so on, an and so on. Suppose if I am going to consider a generating function, let us consider instead of that I am going to consider a generating function like this, 1 plus x square plus x cubed and so on. And of course the function expands by using binomial theorem, then I am going to get this is equivalent to 1 minus x whole to the power of minus 1. And that I am going to represent it in this form. So here, what is a constant coefficient is 1, and x coefficient is 1, x square coefficient is 1, x cubed coefficient is 1 and so on. So this is the generating function for this sequence. For this sequence 1, 1, 1, and so on. So any sequence will be there. That sequence should be a coefficient of constant term, x square term, x cubed term and so on. Then such a function is known as a generating function for that sequence. Suppose if I am considering a sequence is like this, 1 minus 1, 1 minus 1. And I am going to consider an expression whose coefficient, constant coefficient is 1, x coefficient is minus 1, x square coefficient is 1, x cubed coefficient is minus 1 and so on. So this is another generating function for the generating function for the sequence, 1 minus 1, 1 minus 1 and so on. Now suppose if I am going to expand this by using binomial theorem, then I am going to get the expression as like this. So 1 plus nc0, nc1 x, next nc2 x square, nc3 x power 3, because it is 1 is there, here 1 is there. So 1 to the power of n, next 1 to the power of n minus 1, whatever the value is, it is 1 only. So I am going to get the binomial expression for 1 plus x whole power minus n is this. So this is also a generating function for the sequence nc0, nc1, nc2, nc3 and so on, ncn, which is not a infinite. So the remaining terms after n terms all are equal to zeros. So this is the way that we are going to find out the generating function. So now some problems are given. Now we are going to find out what is the generating function to this function. What is the generating sequence? What is the sequence to this generating function? So I'm going to write this as 3 cubed I am taking common. So 1 plus x by 3 whole cube. 1 plus x by 3 whole cube that I am going to get here. So now this is a plus b whole cubed way, or I am going to take it as 27, and this is 3c0 and 3c1 and x by 3 and 3c2 x by 3 whole square plus 3c3 x by 3 whole cube. I'm just expanding. Now this is 27. This is 1. 3c1 is 3, and this 3 and this 3 will get cancelled. So I'm going to get x. 3c2 is also 3. So x square by 9 into 3. Then I'm going to get, this is 3 3 ja, and the next 3c3 is 1. So x cubed by 27. Now if I'm going to taking inside 27, so 27 plus 27x plus 9x square plus x cube. Now what is the coefficients of constant? Coefficient is 27 and x coefficient is 27. Next x square coefficient is 9, x cubed coefficient is 1. The remaining terms are not there. So the remaining terms I am going to write it as 0x power 4, 0x power 5 plus and so on. So I am going to take the remaining terms of the sequence are 0, 0, 0. So this is the generating function for this sequence 27, 27, 9, 1, 0, 0, 0s. Now let us go for this. So for this, how to find out the sequence when our generating function is given. So this is, I am going to expand this 1 plus x square plus x cubed plus x power 4 plus and so on. Then this will become 2x cubed, 2x square, then plus 2x cubed plus 2x power 4 plus 2x power 5 plus and so on. So what are the constant coefficient is? There is no constant term here. Then there is no x term here. There is no x term here. X square coefficient is 2. X cubed coefficient is 2. X power 4 coefficient is 2. And remaining all are 2. So it is a generating function for the sequence 0, 0, 2, 2, 2, 2 and so on. So for this problem now, this is 1 plus x square plus x cubed plus x power 4 plus x power 5 plus and so on plus 2x cubed. Then this I am going to write 1 plus x square will be the same, and this one is 3x cubed plus x power 4 plus x power 5 plus and so on. So what is the sequence of this? Constant coefficient is 1, x constant coefficient is 1, x square is 1, x cubed is 3, x power 4 is 1, x power 5 is 1, 1 and so on. So this is the sequence for this generating function. So here generating functions are given. Now we find the corresponding sequence. Now the next one is sequences are given. Now we have to find out its corresponding generating function. Now here, this I am going to write the constant term is 1 and the x term is 2, x coefficient is 2 and x square coefficient is 3x square, and this is for 4 x cubed coefficient is, this is plus and so on. So this is just this is nothing but one expression of the form 1 minus x whole to the power of minus 2. 1 minus x whole to the power of minus 2. So this is the generating function for this sequence. Now the second one, if I am going to consider, this is also 1 minus 2x plus 3x square, because it is alternatively positive and negatives. So I am going to consider like this. So which is nothing but 1 plus x whole to the power of minus 2. So this is the other generating function. Now if I am considering for this, so this is 0 plus 1 into x plus 2 into x square plus 3 into x cube plus 4 into x power 4 plus and so on it will be. Now for this I am going to calculate the generating function. Take x as common. 1 plus 2x plus 3x square plus 4x cube plus and so on it will be. So this is equals to x into, what about for this sequence, the generating function is this. So it is 1 minus x whole to the power of minus 2. So for this sequence, this is the generating function. F of x is equals to x into 1 minus x whole to the power of minus 2. Suppose for this is nothing but alternatively positives and negatives. So we are going to write it directly. So x into 1 plus x whole to the power of minus 2 for this. 1 plus x whole to the power of minus 2. And now for this, let us how we are going to calculate for this is, we know already the generating function for this. Directly I am taking this is, so what I am going to get, 1 into x plus 2 into x square plus 3 into x cube plus 4 into x power 4 plus and so on. The corresponding generating function as x into 1 minus x whole to the power of minus 2. Now if I am going to differentiate on both sides, differentiate with respect to x on both sides, what I am going to get, 1 plus 2 square into x plus 3 square into x square plus 4 square into x cube plus and so on. So this is nothing but d by dx of, just we have to x into 1 minus x whole to the power of minus 2. Now this is nothing but just this is, I am going to write like this. So this is nothing but this expression. So if I am going to differentiate this, whatever the result I am going to get, that is nothing but 1 minus this derivative is 1 plus x into minus 2 1 minus x whole to the power of minus 3 into minus 1. So I am just taking 1 minus x whole to the power of minus 3 as common. So it is 1 minus x and this is plus, what I am going to get, it is 2x. So this is 1 plus x by 1 minus x whole to the power of 3. This is the binomial, this is the generating function for this sequence. And now for this, this is similar to this is, so what we are going to take, this is, if I am going to 0, the given expression as 0 square into 1 into what I am going to get, this is 0 square plus 1 square x plus 2 square x square plus 3 square x cubed. See here, x square x cubed plus 4 square x power 4 plus and so on. So for this I just took common as x, so then it will become 1 square, 2 square x, 3 square x square, 4 square x cube plus and so on. So for this the generating function is this, x into 1 plus x by 1 minus x whole cube. So this is the generating function for this sequence. Now let us go for the other problem. This is 1 cubed, 2 cubed, 3 cubed, 4 cubed and so on. So now you observe this. If I am going to differentiate this, so 1 I am going to get here, 2 square into x square derivative is 2x. So I am going to get 2 cubed x. Suppose if let us consider this as 1. Then what I am going to get? So by using 1, so it is 1 square x plus 2 square x square plus 3 square x cubed plus 4 square x power 4 plus and so on, which is equals to, so what is given? It is x into 1 plus x into 1 plus x by 1 minus x whole to the power of, I'm just taking it as 3. So which is equals to x plus x square by 1 minus, or I'm going to take it as x plus x square. Then take this to the numerator. Then it is 1 minus x whole to the power of minus 3. Now I'm going to differentiate this. So it is 1 square and next 2 square into 2x. Then it is 3 square into 3x square. Then it is 4 square into 4x cubed plus and so on. So I'm going to differentiate this. So it is 1 minus x whole to the power of minus 3. Derivative of this 1 plus 2x. Then this is UV method, x into x square. Then derivative of this minus 3. And now this will become 1 minus x whole to the power of minus 1. Minus x is a minus 1. So what I'm, instead of taking 1 square, I'm just taking 1 cube plus 2 cubed x plus 3 cubed x square plus 4 cubed x cubed plus and so on. So after simplifying this, 1 minus x whole to the power of minus 3 and then 1 plus 2x, then it is plus 3 into 1 minus x whole to the power of minus 4 x into x plus x square. So here I just took common as a 1 minus x whole to the power of minus 4. I just took common. So it is 1 minus x. It is next 1 plus 2x. Then 3 into x plus x square. So after simplifying this, we are going to get this as x square plus 4x plus 1 by 1 minus x whole to the power of 4. This is the generating function for this sequence. So now let us observe the previous one and this one. In the beginning way, we are just considering a generating function, and for that we return the sequence, corresponding sequence, and the next type of problems we are just given the sequence and we are finding its corresponding generating function. So these are the problems related to that. Now we are going to consider the another example. Then it is if n is a positive integer, then we have to prove this. If n is a positive integer, then we have to prove this. So here, this is a minus NCR. What is NCR is? NCR is equals to n factorial by n minus r factorial into r factorial. This I am going to write it as n into n minus 1, n minus 2 and so on. N minus r minus 1, that is n minus r minus 1. Then next is n minus r by n minus r into r factorial. So these two get cancelled. Finally, I am going to get this. So in this minus NCR I have to calculate. So just I am going to substitute minus NCR is equals to, in the place of n, I am just taking minus ns. I am just take minus n. So now it is minus n minus 2 and so on. The last one is minus n minus r plus 1 by then r factorial. Now this is there are r terms will be there, and I took minus as common, then it will become minus 1 to the power of r. Then if I am taking minus as common, then it will become n plus 1, n plus 2, and so on. This will become n plus r minus 1 by r factorial. So this I am going to get. So this is n plus r minus 1. Now you observe this. This is minus 1 to the power of r. Then in this I am going to write n into n plus 1. So what about I can write this as? I can write this as directly what is n plus r minus 1 cr. What is that? This is n plus r minus 1 factorial by n plus r minus 1 minus r factorial into r factorial. This we have to verify. So there is no n minus 1 factorial term in the denominator as well as the no factorial term in the numerator. So I am just multiplying with n minus 1 factorial on numerator as well as denominator. So I am going to take like this. Numerator and denominator I just multiplied with n minus 1 factorial. Now this will become, so this is minus 1 to the power of r. Then this is the whole thing is n plus r minus 1 factorial by, then it is this I am going to get this as by, then what is n minus 1 factorial into r factorial. So this is minus 1 to the power of r, then ncr in the place of n, this I am having, and n minus 1 ncr. So r is equals to, I am taking this. So this is, which is equivalent to this. I am just to replace, this is here. So this is the proof for this. Minus ncr can be written as minus 1 to the power of r, n plus r minus 1 cr. Because this kind of problems we are going to use while solving the recurrence relation by using generating function. Now let us the same thing whatever we got earlier. So the same I am just multiplying, just taking minus 1 to the power of r, multiply with minus 1 to the power of r on both sides. So this is minus 1 to the power of r minus ncr minus 1 to the power of 2r. That will become 1. So I am going to get this is just I am taking, this is going to be written like this. So this is just because of the previous one. I am just multiplying with minus 1 to the power of r on both sides. So this will become minus 1 to the power of r into minus 1 to the power of r minus 1 to the power of 2r. So I am going to get here, this is a plus, and then this is a same minus ncr. That we are written here. Then taking summation on both sides, same thing, taking summation, and x power r we are multiplying on both sides, taking summation, and x power r we are going to multiply. So this is minus 1 to the power of r and x to the power of r. Then that will become minus x to the power of r. So I am going to write this is the expression for 1 minus x whole to the power of minus n. So instead of taking positive expressions, we know 1 plus x whole power n, 1 plus x whole power 5, whole power 6, and so on. Now we need to calculate what is 1 minus x whole to the power of minus 5, minus 6, minus 7, and so on values. Now, see here, I am going to find out what is the value of this one. So here, this is this we have to prove 2n cn is equals to this. And 2n cn is the coefficient of x power n. So here, I am going to write what is 2n cn. So before finding 2n cn is a coefficient of 1 plus x whole power 2n. So this I am taking 1 plus x whole power 2n. So this I am going to write 1 plus x whole to the power of n and 1 plus x whole to the power of n 2n. Then this I am going to write it as, by using binomial theorem. This is a NCR, then x power r. And this is a NC other variable, NCS, x to the power of s. And of course, s is equals to 0 to n, and n is equals to r is equals to 0 to n. R is equals to 0 to n, and s is equals to 0 to n. Then if I am going to substitute n r equals to 0, nc 0, and the next one is nc1 into x, and nc2 into x square, and nc3 into x cubed, plus and so on, The last one is ncn, and then x power n. This is for first term. Then similarly for the second one, we are going to write nc0, then next one is nc1, x, nc2, x square, plus and so on, plus nc n minus 1, x to the power of n minus 1, plus ncn, x to the power of n. This is the expansion for this. Now I am going to find out, I am going to calculate only x to the power of n coefficient. And throughout this I am going to multiply, and I am going to find out only x to the power of n coefficient. What is this? This and this, if I am going to multiply, I am going to get one term of x to the power of n coefficient. Next, this one and this one, if I am going to multiply, plus nc1, then ncn minus 1. Then this one, plus nc2, then ncn minus 2. ncn minus 2. Like that it will be continuing 0, 1, 2, and so on. This will be increased to n, n minus 1, and so on. It will be increased to n minus n, that is nc0. So now this is equivalent to, I am going to take this as the first one. I am going to write this as summation of NCR for this. Then this I am going to write NCn minus R. R is equals to 0 to n. Now observe R equal to 0, it is NC0, NCn. R equals to 1, NC1, NCn minus 1, like that. So R equal to 0, I am going to get the first term, R equal to 1 second term, R equal to 2 third term, R equal to 4 to fourth term, like that. R equal to n, I am going to get nth term. Now this I am going to write this as, this is NCR, and NCn minus R is equal to NCR only. Now this is nothing but summation of NCR whole square. NCR whole square. So this is the way that we are going to prove this. Now another one is, so this is a small function is there. Then we have to find out what is the coefficient of x power 7, x power 8, x power k in general of any function will be there. Then how to find out this? So for this, so it is given f of x as 1 plus x, x square, and this as 1 plus x whole to the power of n. Then this I am going to write 1 plus x square, 1 plus x whole to the power of n. Then this is nothing but NCR. I am going to write, and next another one is this I am going to take it as x power r. NCR x power r. R is equals to 0 to n. Then this I am going to multiply 1 into this. So I am going to get NCR x to the power of r, 1 into this. Next plus NCR, then x to the power of r plus 1. The next one. And next this one and this one. Next NCR x to the power of r plus 2. Now just I'm going to calculate what is the coefficient of x power 7 coefficient. X power 7 coefficient. So I can keep x is equal to 7, r is equal to 7 here, r is equal to 6 here, r is equal to 5 here. So then x power 7 coefficient is NC7. I'm not going to consider this x power 7 plus this is a NC6, then this is NC5. NC5. X power 7 coefficient. And similarly, x power 8 coefficient if I am going to consider. So just substitute r is equal to 8. So then it is NC8, NC8, r is equal to 7, NC7, and r is equal to 6. So NC6. Now, x to the power of k in general. So it is r is equals to k, NCk. And whereas here, r is equals to k minus 1, NCk minus 1. And next another one is NCk minus 2. So these are the coefficients for x power 7, x power 8, x power in general k, x power in general k. So this is the way that we are going to find out what is the generating function. So here whenever any function, generating function is given, what is we studied what is the generating function definition and corresponding to the sequence. And now whenever generating function is given, how to find out its sequence. Then whenever sequence is given, how to find out its corresponding generating function. Then some of the identities that formulas like minus NCR value is what. And next another one is what is 1 plus R1 minus x to the power of minus n. How we are going to expand. Then how we are going to find out any expression, some powers of x, and what is 2NCn, and what is the value of this. That is nothing but what is the expansion, what is the coefficient of x power n in the expansion of 1 plus x whole to the power of 2n. So these are some of the basic concepts that we need for the generating function, by using generating function to solve a recurrence relation. So next session we are going to concentrate on recurrence relations. What is a recurrence relation and how to solve a recurrence relation, and what are the different types of recurrence relations and all we are going to discuss in the next class. With this, I am going to conclude this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.